Alright guys, I'm going to be taking you through the basic transformation of sine and cosine graphs. To review really quickly, as we know from our parent transformations from back at the beginning of the year, A, H, and K are pretty important to our transformations. A stretches our graph vertically, H moves it left and right, and K moves it up and down. So our basic sine graph always starts at 0, 0, goes up to 1 at pi over 2, back down to 0 at pi, down to negative 1 at 3 pi over 2, and back up to 2 pi for a full period or one cycle. The cosine graph starts at 1, goes to 0 at pi over 2, down to negative 1 at pi, up to 0 again at 3 pi over 2, and is back at 1 at 2 pi. And if you want more explanation as to why that works, you can see one of the previous videos from earlier on in the chapter. An amplitude change changes the distance from the midline to the highest point and to the lowest point. So the basic graph has an amplitude of 1 because from our midline we go down 1, we go up 1. So A in our parent graph, or in our general form, changes the amplitude. So on the sine graph, my starting point is going to be the same at 0, 0, and instead of going up to 1 at pi over 2, I'm now going up to 2. Still back to 0, down to negative 2, and back up to 0. So just changing how high and low I'm going. Same thing with the cosine graph, where I normally would start at 1. Now I'm going to start at 2. Still going to be back at 0 at pi over 2, and down to negative 2 at pi, back to 0, and up to 2 pi again. Or sorry, up to 2 for 2 pi again. The reflection, just flipping it vertically, same thing as with all my other graphs. If A is negative, it's going to flip my graph. So with my sine graph, my negative sine graph, I'm still starting at 0. In fact, my zeros are all the same at pi, 2 pi, and 0. But instead of going up to 1, now I'm going down to negative 1 first, back to 0, and up to positive 1. So just flipping that upside down. Same thing with the cosine graph. My zeros are still the same at pi over 2 and 3 pi over 2, but now I'm starting at negative 1, going up to 1, and coming back down to negative 1. For the vertical position, K, that's going to change where my midline is. My sine graph, if I go back to the top, had a midline of 0. So did the cosine graph, midline of 0. Excuse me. So when I have a different K, so this one is plus 1, this one is minus 1, it changes where my midline is. K basically tells me my midline. So instead of having a midline at 0, I'm going to put my midline at 1, and that shifts the whole thing up. So my original sine graph started at 0, went up 1, back to 0, down 1, and back to 0. So on my vertical position now, I'm starting where my midline is. That's my new 0. Still going up 1, back to 0, down 1, back to 0. So the whole thing gets shifted up. And that's a little bit off, but you get the point. So this shouldn't be dipping below. This should be right there. And then the cosine graph now has a midline of negative 1. So where I normally had a midline of 0 and I started at 1, now I have a midline of negative 1 and I'm starting at 0. My zeros are still on my midline, and I still go 1 below and 1 above. And again, I'm supposed to be going through that point again. That got really messy. So whenever I have a vertical position change, the first thing I would recommend is moving that midline and then centering your entire graph around that midline. It's going to make it a lot easier to keep track of. When I have a change in h, this particular one, x minus h, remember whenever we have x minus, we move it to the right, x plus, we're going to move to the left. H is pi over 2, so that becomes my new starting point. Instead of at 0, I'm now going to start at pi over 2. My pattern stays the same. For my sine graph, start at 0, go up 1, back to 0, down 1. This needed to be wider. And back to 0. And then my cosine graph getting moved over as well by pi over 2. Normally, remember, I start at 1 at 0. 0, 1. So now I'm going to start at pi over 2, 1. But the same pattern keeps going. And again, not quite wide enough. So that's just that horizontal shift. Finally, the period change, and if you're watching this after 5-6, I would stop the video because that's all you're doing for today. However, the period change is the next part that we're going to do, and the period is how many, and this is back up in our original here, B, that's the period change, and B tells you how many cycles you're completing within 2 pi. So normally, 1 cycle is within 2 pi. That's our period. However, if I have 2 times x, what that means, sine of 2x, that means that instead of finishing 1 cycle, going up, down, down, up for 1 cycle, I'm going to do that twice. So I'm going to finish 1 cycle within 1 pi instead of 2. So that means I'm going to go up 1, so up, down, up within pi instead of 2 pi. So that means I'm finishing two cycles within 2 pi. The cosine, that one with that being 1/2 pi, that means I'm going to finish a half a cycle within 2 pi. So if this is 2 pi, I'm only going to get to basically I'm only going to do this part. I'm only going to finish that much within 2 pi. So where normally I would go start at 1, come down here, and do that for my cycle of 2 pi, I'm only going, instead of going to 0 at pi over 2, I'm going to 0 at pi, hitting back down to -1 at 2 pi, and that's my half a cycle within 2 pi. Now, this graph goes to 4 pi, so I'm going to go ahead and finish off that part. So that's stretching it quite a bit wider. So that is the period change, and we'll deal with that a little bit more next class. And that's it for your transformations of trig functions. You may see various ones. The trickiest is when you have both an amplitude change and a vertical change. Always make sure you put that midline, and remember, whatever your amplitude is, that's how much you're going above that midline and how much you're going below it. So, good luck, and see you next class.